After finished the aforementioned preparation work, let's do an exercise. Look, this is a circuit containing two nonlinear resistors. Both of the nonlinear resistors are the current controlled type. The excitation has two parts. One is 7 volt DC, another is a sine small signal. The amplitude and the angular frequency are given. Now we need to find U2. Okay, first, we solve the working point of the circuit. We need to draw the nonlinear circuit for solving the working point. For this circuit, there are 5 variables: I1, I2, I3, U2, and U3. So we need to write 5 independent equations. First of all, we can write 2 KVL equations. Then we use KCL at this node. Besides, we have 2 nonlinear UI relationships. These are the nonlinear algebraic equations about the 5 unknowns. By solving the nonlinear algebraic equations, we can get the working points of all the branch variables. Of course, here we are most interested in the working point of I2, that is 1 ampere, I3, 1 ampere, and U2, 3 volts. Then, we can constitute a small signal circuit from the original circuit. As we taught earlier in this lecture, the small signal circuit and the original circuit have the same topology. The only possible change is the parameter of each component. Now we draw the small signal circuit. The DC voltage source is changed into the short circuit. The AC small signal remains the same. The linear resistor is with the original value, and the nonlinear resistors are changed into linear resistors. We find their values using the working point now. We define them as R2 and R3 respectively. For R2, it's easy to find that R2 equals du2 over d2 at the time of I2 equals capital I2. So it is equal to 1 plus 6 times I2 squared. Substitute it into the formula, it is equal to 7 ohms. Similarly, we know that R3 equals du3 over di3 at the time of I3 equals capital I3. It is equal to 2 plus 3 times I3 squared. Substitute it into the formula, it is equal to 5 ohms. As we know, it's 7 ohms and it's 5 ohms. We have got a linear resistor circuit about delta I1, delta I2, delta I3, delta U2, and delta U3. The linear resistor circuit is easy to solve. We can find delta I1 equals UM sine omega t over 2 plus 5 parallel 7. The calculated value is 0.203 UM sine omega t. After we have delta I1, delta I2, and delta I3 can be gotten by the current division. Delta I2 is equal to 5 over 5 plus 7 times delta I1. By substituting the value into the formula, it is 0.085 UM sine omega t. After we get delta I2, delta U2 equals 7 times delta I2 equals 0.593 UM sine omega t. Next, by combining the two conclusions, we know that U2 equals 3 plus 0.593 UM sine omega t volts. So we finished the analysis of the entire circuit.